Hello everyone, welcome back. In previous lecture, we were discussing about the temperature measurement in the chapter number 5. Now in today's lecture, I will start off with a new chapter. As you can see on your screen, that is this chapter is about the system of limits, fits, tolerances and gauging. Now, these terminologies are very useful in industries from the practical perspective. When we are supposed to check the dimensions of components that are produced in mass scale. Suppose if we are manufacturing a shaft and we want to measure the outside diameter, so what will happen each and every time you will if we you have to use a vernier caliper, what will happen, the time will be, it will consume more time. So instead, what we use gauges that are made of predefined that exact dimension that shows the permissible variation in the dimension is allowed in that gauge. So that gauge is used for repeated measurement of that component. Now we will start with brief introduction regarding this. So first, let us see the syllabus over here. You can see uh, first the definition of tolerance specification in assembly line. Okay, then the principle of interchangeability. So after definitions of tolerances, specification in assembly, principle of interchangeability, then selective assembly, limits of size, Indian standard, concept of limits of size tolerance, definitions of fits, hole basis system, shaft basis system, types of fits and their designation, geometric tolerance, position tolerance, gauges classification, the basic concept of design of gauges using Taylor's principle, then wear allowance on gauge, types of gauges, plain gauge plug, ring type snap, limit gauge material, then the comparators in which the functional requirement, classification, mechanical Johnson macrometer, sigma comparator, dial indicator, electrical principles, LVDT, pneumatic back pressure gauge, Solex comparator, optical comparator, and Juice ultra optimeter. So first let us start with the interchangeability. इंटरचेंजेबिलिटी मतलब जो पार्ट जो है वो हम इंटरचेंज कर सकते हैं, मतलब चेंज कर सकते हैं विद इंटरनेशनल स्टैंडर्ड इफ देर इज वन international standard. Suppose the bolt manufactured over here is to be used somewhere else. So what is interchangeability? That this component will be used over the other parts of the country. Okay, so the term interchangeability is normally employed for the mass production of identical item within the prescribed limits of size. Little consideration will show that in order to maintain the sizes of part within a close degree of accuracy, a lot of time is required, but even then, there will be small variations. If the variations are within the certain limits, all the parts equivalent size will be equally fit for operating in machines and mechanisms. Therefore, certain variations are recognized and allowed in sizes of matching parts to give the required fitting. This facilitates to select a random range from a large number of parts for an assembly and results in a considerable saving in cost of production. In order to control the size of finished part with due allowance for error for interchangeable part is called as limit system. It may be noted that when an assembly is made of two parts, the part which enters into other is known as enveloping surface, which means the enveloped surface or the shaft of for cylindrical part, and the other is in one which one enters is called enveloping surface or hole for cylindrical part. जो होल और शाफ्ट की जो सिस्टम है उसके अंदर जो एनवलपिंग पार्ट होता है वो होल होता है, वो शाफ्ट को एनवलप करता है। जो जो एनवलप सरफेस कौन सी होगी, शाफ्ट और दैट सिलिंड्रिकल पार्ट। नाउ द टर्म शाफ्ट refers not only to the diameter of a circular shaft, but it is also used to designate an external dimension of a part, while the hole refers not only to the diameter of circular hole, but it is also used to designate any internal dimension of the part. So basically, in order to control the size of finished part, which due allows for error, for interchangeable part is called limit system. So remember this, what is limit system? Limit system is nothing but just to control the size of finished part which due allows for error, and that is called as this interchangeability of parts. Next, there are important terms used in limit systems. So we will start off with the various important terminologies you can see in the diagram. So the following terms used in limit system or interchangeable system are important from the subject point of view. That is, the first terminology is limits of sizes. There are two extreme permissible sizes for a dimension of part you can see in the figure. The largest permissible size for a dimension of part is called as upper or high or maximum limit, whereas the smallest size of the part is known as lower or minimum limit. यहाँ पे जो लिमिट्स ऑफ साइज है उसके लिए यहाँ पे दो डायमेंशन हमको मिलेंगे, जो होल है या फिर शाफ्ट है उसके अंदर। सबसे पहला डायमेंशन जो है वो है यहाँ पे लोअर लिमिट, एंड हियर सेकंड वन इज द अपर लिमिट, and the difference between both is called as the tolerance, while the difference between hole and shaft is called as the allowance। यानी कि यहाँ पे जो लिमिट्स ऑफ साइज है वो क्या है, वो दो एक्सट्रीम परमिसिबल साइजेस है फॉर अ डायमेंशन ऑफ द पार्ट। टॉलरेंस का मतलब क्या है, टॉलरेंस यानी कि कोई भी पार्ट है, ठीक है, होल है या फिर शाफ्ट है, उसके अंदर जो डायमेंशनल वेरिएशन जो अलाउड है that is called as tolerance, while the variation between hole and shaft provides the allowance. So allowance can be clearance type of allowance, then the interference type or transition fit allowance. It shows the fitting between the hole and shaft. What is the gap between hole and shaft dimension? While the tolerance is only provided to the single component. That is due to the manufacturing constraint. As we know that the shaft cannot be manufactured to the exact dimension without, okay. So some permissible variation is required in the dimension that is acceptable. That is called as the tolerance. Now, the definition of allowance, it is the difference between the basic dimensions of the matching parts, which means the matching part over here is the hole and shaft, and the basic dimensions, suppose these are the basic dimensions, the difference between both is known as the allowance। द अलाउंस में भी पॉजिटिव और नेगेटिव, जो अलाउंस होगा वो पॉजिटिव भी हो सकता है या फिर नेगेटिव भी हो सकता है। when the shaft size is less than the hole size, then the allowance is पॉजिटिव। जो शाफ्ट की साइज है वो कम है होल की साइज से, ठीक है, तो वो अलाउंस क्या होगा, पॉजिटिव। जबकि शाफ्ट की साइज ज़्यादा होगी होल की साइज से, तो वो अलाउंस कैसा होगा, नेगेटिव। नेक्स्ट, nominal size. Now, it is the size of a part specified in the drawing as a matter of convenience. जो ड्राइंग के अंदर जो हम साइज इंडिकेट करते हैं, ठीक है, दैट इज कॉल्ड एज द नॉमिनल साइज। देन देयर इज द बेसिक साइज। Now, the basic size is the size of a part to which the all dimensions of variation, which means the tolerances, are applied to arrive at final dimensioning of matching parts. The basic size is the size of part to which the all limits of variation, which means the tolerances, are applied to arrive at the final dimensioning of matching parts. The nominal or basic size of part is often the same. जो नॉमिनल साइज है या फिर बेसिक साइज है पार्ट की, वो ऑफन सेम भी होती है। देन देयर इज एक्चुअल साइज। इट इज द एक्चुअल measured dimension of the part. The difference between the basic size and actual size should not exceed a certain limit. Otherwise, it will interfere with the interchangeability of the matching part. जो बेसिक साइज और एक्चुअल साइज में डिफरेंस क्या है कि बेसिक साइज मतलब जो पार्ट की जो साइज है टू विच ऑल द लिमिट्स ऑफ वेरिएशन आर अप्लाइड, विच मीन्स सब द लिमिट्स ऑफ वेरिएशन आर टू बी अप्लाइड to the arrive at the final dimensioning of matching part. A nominal or basic size of the part is often same. Then the actual size. Actual size is the actual measured dimension of the part. The difference between the basic and actual size should not exceed certain permissible limit. Otherwise, it will interfere with the interchangeability of matching part. जो matching part की interchangeability है, उसको वो interfere करेगा. Next is the tolerance. Now, it is the difference between the upper limit and lower limit of dimension. In other words, it is the maximum permissible variation in the dimension. The tolerance may be unilateral or bilateral. Unilateral का मतलब वन साइडेड, एक ही साइड पे टॉलरेंस है, मतलब पॉजिटिव है या तो फिर नेगेटिव टॉलरेंस है। और बायलेटरल का मतलब दोनों टॉलरेंस है, पॉजिटिव और नेगेटिव। दिस इज द bilateral. It can be when all the tolerance is allowed on the one side of the nominal size. Only one side of nominal size, which means the here the first tolerance is 20.00 and another is 20, up to tolerance is minus 0.004, which means 19 point something, 19.996. So up to that size the variation is allowed, and that is called as unilateral tolerance. Then it is said to be unilateral system of tolerance. The unilateral system is mostly used in the industries as it permits the changing the tolerance value while still remaining the same allowance or type of fit. When the tolerance is allowed on the both sides of nominal size, it is called as bilateral tolerance of system. यहाँ पे दोनों साइड पे टॉलरेंस दिया गया है, प्लस और माइनस, प्लस 0.02 और माइनस 0.02. The plus side is called as the upper limit while the minus side is called as the lower limit. And the method of assigning unilateral and bilateral tolerance here you can see in the figure. So this is about the tolerance. Then there is one tolerance zone. It is the zone between the maximum and minimum limit as shown in figure. And there is one zero line. Zero line is a straight line corresponding to the basic size The deviation are measured from this zero line. The positive and negative deviation are shown above and below zero line. So here you can see all the tolerance zone and all the parts in this single diagram. So up to this we will keep today's lecture. In next lecture we will discuss some more terminologies regarding this and further topics. Thank you very much for listening me carefully. Have a nice day.